Example 1, factor using the decomposition method. In the decomposition method, we're decomposing or breaking down the middle term, and we're rewriting it using two new terms. To find the two new terms, we have to determine the product and the sum using the numbers in our expression. The product is obtained by multiplying the outside numbers together. So in this case, it would be 18. The sum is the coefficient of x, or the coefficient of the middle term here, and it's 11. And now you're going to look for two numbers that multiply to give you 18 while at the same time adding up to 11. Those two numbers are positive 9 and positive 2. Okay, now we're going to replace 11x with two terms. One of those terms will be 9x and one of them will be 2x. So I'm going to write 3x squared plus 9x plus 2x plus 6. Okay, and then I'm going to factor by grouping. So I'm going to take the first two terms and the last two terms and remove a common factor from each. So from the first pair, the greatest common factor is 3x, leaving me with x plus 3. In the second pair, I see that the greatest common factor is positive 2. And if I divide these two terms by 2, I'm left with x plus 3. Now I can remove the binomial factor of x plus 3, leaving me with the second bracket of 3x plus 2. So this would be the factored form. And I just use decomposition, or the breaking down of the middle term, to obtain the factored form. Let's look at another example. My product in this case would be negative 20. 4 times negative 5 is negative 20. My sum is negative 8. Okay, so I'm looking for two numbers that multiply to give me negative 20 and at the same time add up to negative 8. Okay, those two numbers are going to be negative 10 and positive 2. Breaking down the middle term, I get 4x squared minus 10x plus 2x minus 5. Factoring by grouping, we get as the greatest common factor from the first pair, 2x, followed by 2x minus 5. From the second pair, I can only factor out a 1, and the bracket that will remain is 2x minus 5. So 2x minus 5 is the common binomial factor, and the second factor would end up being 2x plus 1 if I divide both of these by 2x minus 5. Moving on to the last example here, I'm going to figure out the product by multiplying the outside numbers, and 12 times 12 gives me 144. The sum will be negative 25. So I'm looking for two numbers that multiply to give me 144, while at the same time adding up to negative 25. And the two numbers in this case would be negative 16, and negative 9. Okay, so breaking down my middle term, I end up with 12x squared minus 16xy minus 9xy plus 12y squared. Grouping my terms together and then factoring, I get 4x as the greatest common factor of the first two terms. In brackets, I would end up with 3x minus 4y. For the second pair, since the first term starts with a negative, I have to factor that out. And then following the negative sign, I would get 3y as my common factor. Dividing these two terms by negative 3y leaves me with 3x minus 4y. So the common binomial factor is 3x minus 4y, and the remaining factor would be 4x minus 3y. Notice that since the first term was contained an x squared, the first term in each bracket has to contain an x. And since the last term contained a y squared, the last term in each bracket has to contain a y.